Hey y'all, today we'll be discussing hostname resolution and demonstrating the various configuration files that make it work. Before we begin, I'd like to thank one of my commenters for suggesting this video topic. It's a great idea. I hope this video helps you out. As usual, we're going to be focusing in on one of the RHCSA exam objectives, and that objective is configure hostname resolution. So to start, here's the deal with hostnames. We basically want a user-friendly way to refer to hosts on our network instead of using IP addresses all the time. So we give individual systems a special name called a hostname. To make use of these names among many systems, we tackle this with various forms of hostname resolution, so systems can access each other by those names. There are two major ways this is handled on Unix-like systems, and even Windows. The first way is with a local table of IP addresses and corresponding hostnames, stored in a file called hosts in the etc directory. This file usually takes the highest precedence, and we'll get into why that is in a little bit. The small issue with this setup is that if IP addresses of the systems are dynamically assigned, then the entries in the host file won't work for very long. Static IP configurations will be okay though. The second major way hostnames are handled is through the use of the domain name system, also known as DNS. DNS is a protocol on port 53 that works between a client and server to translate hostnames into their respective IP addresses. Domains, by the way, are a way to group the hosts on our network. So to clarify, a hostname is a type of domain name, and a domain name can also be your hostname if you configure it to identify by that domain name. To help all of that make more sense, here's a look at what I mean. So here we have our host, my server, and we have a DNS server that knows the IP address of my server and its hostname. So depending on the configuration of the DNS server, it can assert that my server, as well as the other hosts on the network, belong to the domain lab. So the FQDN, or fully qualified domain name of the system, is myserver.lab. Our system's hostname could just also go by that fully qualified name, myserver.lab, as its hostname, and this would only make things more consistent across the board. The DNS server can effectively group my server under this lab domain because it's the default DNS server in this scenario. All of the machines on the network are configured to consult this specific DNS server for the domain names of systems. This DNS configuration is often rolled out using DHCP, the Dynamic Host Configuration Protocol, but it can also be done manually as well. DNS can recurse its resolution and operate in a hierarchy of servers. For example, our DNS server can consult another DNS server and so on for more information. This is known as DNS resolving. A good example of this is your local DNS server contacting Google's DNS server for a name it doesn't have the IP address for. This search can walk up the chain to top-level domain servers for domains like .com and even higher up to authoritative servers that really have the original say on the assignments. To make this faster and more lightweight, most DNS servers use caching to avoid needing to deeply resolve every request. And now, when it comes to local configuration, DNS is configured with the resolv.conf file on Unix-like systems, which is also stored in the etc directory. Usually this file is populated by another program that knows the right IP address of the DNS server. Knowledge of that IP address could come from DHCP or a manually set configuration. This search part is for specifying the local domains that the resolver should search in. So effectively, this appends the domain to the local host names you search for. So a request to other server would go out as otherserver.lab. On Enterprise Linux 9, the way you configure network settings like these is through a daemon called Network Manager. This is also what writes the resolv.conf file. Like I was getting at before, having names is also really handy for cases where the IP address assignment is dynamic, meaning that it changes on a regular basis. So the name can stay the same while the IP address can change. This is called dynamic DNS, by the way. And to touch back on DHCP, the systems on our network can communicate their preferred hostname to the DHCP server, which in turn can be used to request an update to the DNS server's table to make the whole setup all the more dynamic. Anyways, what ties together the priority of these configurations is a file called nsswitch.conf. This is the name server switch file, and it's used by programs that want to resolve a name in the correct order. As you can see, the default on Enterprise Linux and most other distributions is to check the host file first, and then to check DNS by querying IP addresses in the resolv.conf name server section. Okay, now one more thing that I'll talk about as I was asked about it is the named.conf file. This configuration file is used by the bind DNS server called named. So if you recall back to my video about setting up a NAT router, you'll remember that I used a DNS server called DNS mask. Well, this is a similar service, and at the end of the video, I'll set up a basic instance of named and demonstrate how it can be used as a DNS server in the home lab. We'll even see if we can get it to work together with our existing DNS mask server so we can resolve special names that only named knows how to sort out. That'll be a good example of resolution. So, I hope this presentation was a good visual to help make all of that information digestible. What we'll be doing now is playing around with our virtual lab to get to know the configuration files a little better. Then, like I just said, we'll try to play around with the named server. Alright, so here we are on our workstation, and this is where we can start trying some stuff out. So first and foremost is the hosts file. So we'll grab a root shell and vim right into that. So in here is that address to hostname alias table that I was talking about. So let's try an example. First, we'll jump out of Vim for a second and try to ping a hostname. So we'll ping ibm.com, and this is a host outside of our local network. And as you can see, it's working as it should. We're effectively reaching one of IBM's servers. So let's cancel that, and let's use the host file to manipulate this. So we'll go back to Vim, and we'll add an entry to host that takes requests to the name ibm.com and other aliases like www.ibm.com, and send it to our loopback address 127.0.0.1. So we'll add a new line and type in 127.0.0.1 and then ibm.com and www.ibm.com if you want. So there we go, we can just right and quit the file. And now if we try to ping ibm.com again, we'll see that all of the pings are going to our local host instead of IBM servers. So that was pretty easy, and we just changed how this particular system will resolve the name ibm.com. You could take this a step further and use this as a basic way to block website domains by sending all of the requests to your local host instead of to the actual server. Of course, such a change will only ever affect this system, so let's move into something more powerful. And that is DNS. So once again, we'll ping one of our hosts, but this one will be a local VM on our lab network. So we'll just ping appserver3, and as you can see, we're able to reach that host by its name, appserver3. Technically, appserver3.labnet. So we're also able to ping servers on the internet, like youtube.com. That's working well. And now let's open our resolv.conf file and edit the line for our DNS server. So we'll just vim into etc resolv.conf, and let's edit this name server section. So instead of 10.0.0.1, we'll change it to Google's DNS server 8.8.8.8. We'll right and quit the file, and now let's try to ping appserver3 again. As you can see, it's not working anymore. We can't resolve that name. However, we can still reach that system if we ping it by the IP address that we saw before. So that's 10.0.0.8. So we'll just try that. And that still works. On the other hand, we can still reach youtube.com and any other names understood by Google's DNS with no problems. Now, what we just did isn't going to persist on most systems because a daemon like Network Manager or DHCPCD is going to overwrite this file every time. I can demo that real quick by just restarting Network Manager, so we'll just do that. And now if we cat etc resolv, we'll see that the file reverted back to normal. So if you wanted to make this change permanent for whatever reason, you would do that through the Network Manager configuration tools like nmcli or nmtui. Now another thing I'll take a look at is nsswitch.conf. So let's open that up. So let's see here. Going past the comments, you'll see that there are a lot of entries in here beyond what I just showed in the presentation. There are ones for resolving user account names, passwords, groups, and so on. But we'll be focusing in on the hosts part. So this is the order that programs running on our workstation will look for host names / domain names. First is the etc host file, and next is the DNS, so that's etc resolv. And the last is a plugin called myHostname, which will check locally on the system if it can't resolve anything else. I'll quickly demo that plugin if it wasn't clear enough. So we can just move myHostname to the front of the list, right and quit the file, and now we'll ping our own hostname. So ping workstation. Now as you can see, we're still able to reach workstation. However, that .labnet domain name is nowhere to be seen. And that's because we're not querying DNS for the name anymore. So now if I go ahead and remove what I just added and try again, the domain labnet is tacked onto our hostname again because we're going through the DNS server. Okay, back to nsswitch. Let's change the order around even more. So instead of the host file being first, we'll make DNS the first one. Now just writing and quitting again. And if we try to ping ibm.com, the name that we modified in the etc host file earlier, you'll now see that we're directed to the actual IBM server again. So our settings in etc host have been ignored, with DNS now being the first in order. So now let's just cancel that and change everything back to the defaults. Alright, so outside of just the files themselves and using ping, there are a couple of cool utilities that can work with names. So go ahead and install bind utils and net-tools, just like so. So the particular commands that I'll bring up are dig, host, and getEnt. So dig is the domain information groper, and it's used to query DNS servers. Host is a similar command that also queries DNS and has a simpler default output. The thing with both of these commands is that they are used for DNS specifically, not really anything else. GetEnt, on the other hand, queries entries by following the order defined in nsswitch.conf. So if I say getEnt hosts ibm.com, we'll get the IP address of ibm.com just like so. And if I say getEnt hosts localhost 4, we'll get literally the exact line that comes out of etc hosts. Alright, so the last thing we'll be doing is playing with some DNS servers. So the commenter I mentioned at the beginning of the video has basically encouraged me to learn more about named. I'll be honest, the only DNS server I've used prior is DNSMask, so this was pretty new to me. I've gotten a basic configuration of named working on my App Server 3 system right here. The basic configuration boils down to allowing the service to listen on other than just your loopback, and also to allow queries from your internal network. So that's this. Then down here I created a zone called App Server 3, and it refers to this file called forward.appserver3. So I'll just jump over to that. So I've basically gotten it to know how to resolve the domain name router.appserver3 out to 10.0.0.1, and I also made an alias for Yahoo that goes out to yahoo.com's IP address. It can also work for getting IP address of hosts on the web, just like I had DNSMask able to. So I set up a forward zone here with some basic options I learned about from fedoramagazine.org, which I'll link to in the description. And I'll be honest, this is probably not the best way to do it, but it works well enough to demo one DNS server resolving through another DNS server. So anyways, what I did next was I set up my NAT router net server to use DNSMask first, and then to call out to AppServer3 for domain names it can't resolve itself. So that can be seen here in dnsmask.conf. I set the server for DNS to 10.0.0.8. So what this does is that when DNSMask can't resolve a name, it's going to cry out to this server, which is AppServer3, to try to resolve the name. And if AppServer3 can't resolve the name, then it goes out to the outside DNS server. So that's probably just Google's 8.8.8.8. So now if I go back to Workstation, which is the client in this scenario, Workstation can use NetServer's DNSMask server to resolve names just like before, but it can also further resolve additional names through named running on AppServer3. So I'll first just demo that we can still access host names on the internet, and that still works. So ping youtube.com, so that works well. And we can also just ping net server just like before. So we can still access hosts on our network by hostname like that with the domain labnet. And if I want to ping Yahoo through AppServer3's named server, I would do ping yahoo.appserver3. And now I'm pinging Yahoo's IP address through AppServer3 as the DNS server. And so that went through DNS mask as well, which is what I wanted to point out. So I hope this was a worthwhile demo of DNS resolution recursing from server to server. That's going to wrap it up for this video. So thanks for watching.